And what we get with these ultrafine bubbles is the ability to have tremendous surface area in a fermentation. So this is very important because in a fermentation, we're trying to move nutrients and gases to cells. And these bubbles are really, really good microcarriers to be able to move those nutrients and gases to the cells where they're needed and boost their growth and their outputs. So the average for an ultrafine bubble is typically 100 to 300 nanometers. Ours are 100 and below. So we're seeing a lot of smaller ultrafine bubbles. So this is, again, more surface area, more pressure in these bubbles, which means they can deliver more gas. And a smaller particle, a smaller ultrafine bubble, moves faster. So that really helps even mix tanks and move nutrients even more effectively than these larger bubbles. It also means they're more stable. On the fermentation front, we're noticing these ultrafine bubbles are really effective at reducing what's called the lag time, so the time it takes for the cells to really start to grow quickly. So we can reduce that by up to 25%, so that means overall shorter fermentations. And we're also noticing that we can produce higher cell biomass with the same amount of sugar that goes in there. So we're being very efficient at the sugar and the carbon sources that we're using, which means less cost inputs. And then also on precision fermentations, we're noticing higher titers of coming out of these fermentations too. So again, these bubbles really seem to invigorate the growth, really boost the performance of that fermentation. So we work with lots of academic labs internally and then with clients too. So for example, we have collaborations right now with the University of Illinois, the IBRL lab there in Urbana-Champaign, and they have a pilot facility where we've done a 400-liter scale fermentation looking at how these bubbles can affect E. coli in their growth there. We've seen really meaningful benefits in terms of speed of growth, so much faster with the bubbles and higher biomass too. We have internal microbiology capabilities, so we do things on the bench, in shaker flasks, and in 100-liter bioreactors. And then with clients, we're able to work with them by actually even shipping water that has ultrafine bubbles in it, so they can do proof of concept work, and then eventually giving them our technology so they can continuously infuse and get the biggest benefit that way. The tech sits right next to a bioreactor, and essentially what we're doing is called a pump over. So we're pulling the liquid, including the cells, out of the bioreactor. It goes through our tech, which imparts the ultrafine bubbles, and then that liquid goes back in the tank. We do that on a continuous loop. And this way, we're able to replenish the bubbles that have been destroyed or been consumed during fermentation and add more as the cells are dividing and doubling.